Hello everybody, welcome back to the Gregorius Maths video. Today we're going to be considering this famous integral. Now, in general, everyone knows the Gaussian integral. You do the double integral, bish bash bosh, you're done. You know what I mean? You change the variables and that's it. Okay, cool, everyone knows that. But this one, everyone does Feynman. Everyone does Feynman for this. Oh, look, I can differentiate with respect to alpha, and oh, the ln x cancels out. Isn't that amazing? Oh my days, I'm so clever. No, there's a much easier way. And you know, I've just decided, when I first recorded this video, I did it in the case of alpha equals 1, because that's how it was on a question that I did, and during one of the study streams, and I thought, okay, let me just make this cheeky little appetizer, and you know, I'll clickbait by putting Feynman in the title, but really, you know, at least Feynman gives you the general result. And as I was watching the footage, I realized, wait, I can get the general result anyway, and it's still way easier than Feynman. So, you know what, if you use Feynman for this, then I'm afraid, you know, I just don't have any words for you, mate, to be honest. Because look, I mean, listen, okay, look, this is just the integral from 0 to alpha of x to the y dy, because if you think about it, the derivative of n to the x is just n to the x ln x. So, you know, if we treat x as a constant here, this is just going to be 1 over ln x, x to the y, evaluated at y equals 0 and y equals alpha. Obviously, you can prove this by just writing this as e to the ln xy. Okay, whatever. Now, plug in the boundaries, you get that this is just x to the alpha minus 1 over ln x. Oh, look at that, it's right there. Oh, it's getting spicy. Okay, look, let's just plug this in. Okay, this is just the integral from 0 to 1 of the integral from 0 to alpha of x to the y, dy, dx. All right, so what, you might say? Well, listen, there's a guy called Fabini, and he says, you know what, mate, you can do the integrals whatever order you like. And to him I say, thank you, I will. And so look at that, we just do the integral from 0 to alpha of the integral from 0 to 1 of x to the y dx dy. And then this right here is just 1 over y plus 1 if you do it. So this is just the integral from 0 to alpha of 1 over y plus 1 dy, which is just ln alpha plus 1. Like that. And that's exactly what this is. No need for solving any differential equations. No need for any messiness. Just do some double integrals, swap the order of integration, and Bob's your uncle, you know what I mean? So yeah, this was just a little appetizer. You know, I plan on making much longer videos over the course of this exam season on some of my favorite theorems on the various courses I'm doing, in order, as a way of memorizing those theorems, but also giving you guys some entertainment. But yeah, hopefully you enjoyed that. Hopefully you thought of this is a little cheeky little trick. I'm not sure if anyone's done this on YouTube. I'm sure someone has, because this is such a famous integral. But yeah, I just thought might as well give you a little appetizer while you wait for the main course. But with that said, I'll see you guys tomorrow on the study stream. Ta.